So in the reaction where we have the balloon that lights, the hydrogen lights on fire, what we started with was zinc, which is in a solid form. Okay, so zinc is a metal, okay, and on our posters we use blue for metals and yellow for nonmetals, okay, and it's here on the periodic table, right here. Okay, so it has 30 protons, 30 electrons, and 65 minus 30, 35 neutrons. Okay, it doesn't show the charges on this periodic table, but it has a 2+ charge. That means it is going to give away 2 electrons to whoever is going to take them. Okay, and so in our Bohr models, the people would have made 30 protons, okay, 30 of the yellow or green, and 30 electrons, so 30 Fruit Loops, and then they would have had 35 neutrons, so the other color of the Fruit Loops there. Okay, and doing our orbitals, okay, you'll notice that on the outermost valence shell, okay, the outermost orbital, there is only 2 electrons. Okay, it's really hard for a material to hang on when there's only 2 electrons. So it's more likely that they're going to get ripped off by something else because they want a full octet. So having this layer by itself is actually what wants to happen. Okay, so when we react zinc, okay, these are reactants. Okay, with some math on top. Reactants. So we took our hydrochloric acid, right? So this is actually ethyl alcohol, but it was in a bottle, similar to this. And they react to form. This means react to form. It's not equals. Okay? And then we had products. So we made hydrogen gas. That's what this is for. In brackets, it's gas. And hydrogen comes in 2 packs. Okay? So hydrogen usually, this fell off. Okay, that's marshmallow. Hydrogen just has 1 electron, right? So the atomic number is 1, so there's 1 proton, 1 electron. So hydrogen does not like to exist like that by itself as a molecule. Okay, so what instead will do is it will share electrons with another hydrogen. Okay, and you get 2 in a molecule. Okay, so hydrogen gas is what's produced, and that's what we lit on fire because it's very flammable, right? If we look at our properties, okay, it reacts with oxygen when ignited with a spark, okay, and that's called combustion usually, okay, but in this case, the reaction we're showing is not the hydrogen combustion part, it's the zinc and hydrochloric acid reacting to form the hydrogen in the first place, okay, which is what we want so that we can do the reaction. Okay, and then we also have zinc chloride being formed. So how I know to put this ZnCl2 here is when we're doing ionic naming, we need to use the charge. So we've taken our zinc and our 2+ charge, which we looked up on the periodic table, okay, and we have chlorine, and it has a 1- charge. Okay, chlorine is one of the halogens. It is in this row, and it's very reactive. Okay, it likes to react. These noble gases don't. They already have a full octet. And if we look at chlorine, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, 7. It really wants to take some electrons from somebody. Okay, but it can only take 1, right? So it can only take 1 electron. It's going to take more negative charge. So to balance out our 2 that the zinc wants to give away, we're going to need to take another chlorine atom to take the other electron. Okay, so we have 1 zinc and 2 chlorines that we need. See, zinc. Okay, we just don't write the 1. And 2 atoms of chlorine, ZnCl2, zinc chloride. Okay, so if we're writing these in words, okay, this is zinc chloride, 2 words. Okay, hydrogen gas. Hopefully I'm not making you too dizzy, waving my camera around. Hydrochloric acid, and this means AQ, aqueous. And we haven't learned how to name acids, but you can see what's in it, right? Hydro for hydrogen, chloric for chlorine, and then zinc was just a solid. Okay, so zinc metal. So let's continue with our combustion of hydrogen, because we made the hydrogen and we ignited it, we lit it on fire, so we added oxygen. Okay, that's a combustion reaction, so these are our reactants. Reacts to form water vapor. Okay, that is the only waste product. Okay, so it's very clean, and that's how come they burn it in shuttles, right? They have hydrogen and oxygen, and you see all that steam coming from the bottom of the rocket going. Okay, it's not bad for nature at all. Okay, and that's something we want to do. We want to invent hydrogen fuel cells and things that only burn hydrogen safely. Okay, but like we noticed in our experiment, it's very easy to blow up. So we need to make sure we are able to do that safely. Okay, one more thing while we're thinking about it here for grade 10 teachers, they wish we would teach this, but we don't usually. It's called balancing equations. So we want to have the same number of atoms on each side of the equation. Okay, so on the reactant side, we have 2 hydrogens. On the oxygen side, we have 2. Over here, though, we have 2 hydrogens and only 1 oxygen. So we're going to need 2 molecules of that. So now 2 times 2 is 4, so I have too many hydrogens. So I need 4 here. Okay, 2 times 2 is 4. So now they're balanced because we have 2 oxygens. 2 times 2 is 4 hydrogens. 2 oxygens, good, we're balanced. And then 2 times 2 is 4 hydrogens.